for question 18, it seems you have done part B and part C quite well. Okay, so for part A, it seems you left out the rest of the calculation, but the thing is that part A is very similar to part B, okay? Uh, let's go through part A very quickly and I'll tell you what are the similarities between part A and part B, okay? So, you see 10 cm cube of a hydrocarbon is exploded with 110 cm cube of oxygen, and the total volume after the explosion is 85 cm cube. So total volume after the explosion, which decreased to 35 cm cube on shaking with excess sodium hydroxide. And all of them measure at RTP, so you have to make sure that the liquid water, the physical state of liquid water is liquid and not in gaseous state. Then you just need to write the balance equation as well as deduce the molecular formula of the hydrocarbon. So notice over here that the question phrasing is very similar to that of B. If we look at B, 20 cm cube exploded with 150 cm cube of oxygen. The resulting gaseous mixture is also known as the total volume after the explosion is 130 cm cube. When you pass it through sodium hydroxide, the final volume decreased to 90 cm cube. So essentially the phrasing is very similar whereby, okay, you're talking about the resulting gaseous mixture after the explosion and the final volume decreasing to, okay. So in that sense, we're not talking about a contraction of the volume of gases, but we're talking about the final volume of gas after a certain event has taken place. So in that sense, these two questions are very similar. I hope you can try to do this on your own. Okay. Other problems that surface out in the workings of in your own workings is that for balance equation, it is preferable that you simplify the equation. So in that sense, your fractions, some of them are not simplified. You need to simplify those. Okay. And the fact that you use an equal sign to represent the molecular formula, you use equal sign only when you're talking about numbers and not chemical formulas. So you should write a sentence telling me that the molecular formula is a certain molecular formula. Okay. Yeah, right. And if you want to write a chemical equation, right, yeah, you have to put the chemical formulas and not just some rough working. If not, the examiners would be very confused. Okay. So I'll go through part D. This one is the one that I think you have major issues. Okay. So we will just read through the question first. Alcohol J, which is having this molecular formula of CXHYOH. Yeah, all these are the other details. Okay. When 0.10 cm cube of liquid J was dissolved in an inert solvent, an excess sodium metal, 10.9 cm cube of the gas measured at RTP is produced. You see another case scenario when 0.10 cm cube of liquid J is combusted in excess of oxygen. The volume of gas was reduced by 54.4 cm cube. RTP, you add excess NaOH, there's a further reduction of 109 cm cube. Okay, so notice the phrasing over here by and then further reduction. So this is also indicating that the volume decreases by 109 cm cube. Okay, so and then they tell you to deduce the molecular formula, right? We first go through the normal approach. Okay, so what is the balance equation? Notice there are two different reactions occurring over here. So this is reaction 1 and reaction 2. Okay, so reaction 1 over here, you see liquid J, so CXHYOH. Okay, is reacted with excess sodium metal. Sodium metal will be Na solid. Okay, and then a gas is produced. Okay, so in this sense, how you want to form this chemical equation, even though you may not know the reaction, right, is that, okay, you can think of this as a metal acid reaction where you can see this is an acid with a H plus and this one is a metal. Okay, a metal and acid reacts together to form a salt and hydrogen gas. Okay, so hydrogen gas will be H2 gas, and the salt will be CXHYONA. Okay, so this one, put it in liquid state, right? Because there's no water present over here. Okay, so from here, how do we balance the equation? We just see that, okay, the common thing is here, here is all balanced already. Now I got 1H on the left hand side and 2H on the right hand side. I put a half here. Of course, I would not preferably want fractional coefficients, so I will multiply all of them by 2 on all sides. Okay, so this is the first equation. And second equation is the combustion equation. So CXHYOH liquid plus O2 gas, and then gives you CO2 gas plus water. Anything that has carbon, and if it combusts or it reacts with oxygen, always produces carbon dioxide and water. Okay, so from here, okay, yeah, so from here you just need to see how to balance it. We balance carbon first, X. For water, you see is Y plus 1 on the left hand side, so Y plus 1 over 2, right? Y plus 1 over 2. Then if we check for oxygen, 2x plus Y plus 1 over 2. Then you divide this whole thing by 2. Okay, then you get x. Okay, so divide this whole thing by 2, you will get x plus y over 4 plus half plus 1/4. Okay, y over 4 plus 1/4. Okay, x, let's check. Yeah, alright. So this is correct. So x plus y over 4 plus 1/4. Okay, then afterwards we decide what is the limiting reagent and excess reagent. Okay, so it's clear that the limiting reagent here is liquid J. This one is also liquid J. Okay, because you can clearly see excess sodium metal, excess oxygen, so they settle the limiting reagent for you. Okay, then we're gonna see what kind of formulas can we apply for this equation. So maybe we start off with reaction 1. Okay, we know that the volume of hydrogen okay. Actually, before I go on to the carry on with applying the formulas, then I want to let you know there's two important key factors in this question. So there's two important key factors that you must take note that is very special for this question and is not seen in other questions. So first factor is that your mole ratio cannot be equal to your volume ratio anymore. And because you have a liquid present in the chemical equations. Okay, so this one is because alcohol J is a liquid. And second problem is that, okay, they give you two different reactions over here, and notice that liquid J is presented in a volume. So we have the volume of liquid J, which is equal to 0.10 cm cubed, and this is not gaseous. So I need to find a way to determine the number of moles in liquid J. And this is definitely not equal to 0.10 cm cube divided by 24,000 cm cube, because this is only applicable if J is a gas. Okay, so only applicable if J is a gas, right? So after taking these two things in mind, right, we work out the first equation. Okay, so you see that the volume of hydrogen gas is given to be 10.9 cm cube, right? So because the mole ratio is not equal to the volume ratio, the mole ratio is not equal to the volume ratio, I cannot do this. Okay, right, I can't do this. So if I can't do this, this means I need to express this in N. Okay, right, so we need to find the number of moles of hydrogen first. 10.9 divided by 24,000. Okay, so that I can find out the number of moles of the alcohol. Which is given to be 0.0009083 mole. Okay, so afterwards we look at the reaction 2 over here. Okay, so reaction 2, we are given what is the reduction in the volume of gas after the reaction and after NaOH is added. So if I were to draw a diagram, okay, so initially CxHyOH plus excess total O2. Afterwards, the reduction of gas, it means that there's no more alcohol because it's a limiting reagent. Now I have unreacted O2 left plus CO2 plus H2O. But because in this case you are reducing the temperature to RTP, that's why there's no water in this equation. Okay, after that you go through the addition of NaOH, so therefore you have unreacted O2 left. Okay, so now we take a look at what this reduction of gases translate to. So 54.4 cm cube, it means between the initial volume before the combustion and the final volume after the combustion. So this is the initial volume before combustion and final volume after combustion. Okay, sorry, take note, actually this one should be also not there because this is a liquid. Okay, so over here we just need to take total VO2 minus V unreacted O2 minus VCO2 to give you 54.4 cm cube. Then the next part, so this is 54.4 cm cube. And the next part is before and after the addition of NaOH. So here this system is the initial volume before NaOH. This is the final volume after NaOH. Okay, so when you compare, you realize that it's only the volume of carbon dioxide gas, which represents 109 cm3. After all, if there's a reduction of gas after adding NaOH, it means that the acidic gas is being absorbed, which is CO2 over here. Okay, so if you want to make use of these two equations, realize that this whole thing actually translates to V reactor O2. Okay, so if I were to form another equation, so it would have been V reactor O2 equals to 54.4 cm3 plus 109 cm3. And this gives you 103.4 cm3. Okay. Once that is done, then I want to translate that to mole ratio. So reacted O2, okay, and CXHYOH, okay, and then I need to look at what is the mole ratio here. So X plus Y over 4 plus 1 over 4 over 1, and the reactor O2 you have to take 163.4 over 24,000, okay, over this NCXHYOH. You must be wondering how do I find this? Okay, remember in the earlier part of the question they said 0.10 cm3 of liquid J in reaction 1 and in reaction 2. So in that sense, whatever number of moles 0.10 cm3 contains, which is in this case here, so in 0.10 cm3 of J, which is 0.009083 mole. This one will also contain 0.000983 moles as well. Okay, so over here is in 0.10 cm3 of liquid J. So in this sense, this one will have been 0.000983. Right. And then you already form one equation over here. Again, there's also another equation you can form. The thing is that you have two unknowns over here, so you have to find something else to base this off. Alright, so notice that I have the carbon dioxide volume and also the number of moles of alcohol J. So in that sense, I can form another equation over here, so NCO2, just to find X. Okay, HYOH, this is 109 divided by 24,000, 0.000983. Okay, so once you've done that, you actually get X over 1. Which is also equals to 5. Okay, so once you do that, you go back to this area. I think maybe I'll just you go back to this. Okay, sub it in. Don't be intimidated by the large number of numbers you see over here. Okay, so this one will have been about 7.495, so you can just put it as 7.5. Okay, so 7.5, this one will have been around 15 over 2. Okay, so 15, 7.5 minus. Okay, so this one would have been 7.495. Yeah, 7.495. Right, then afterwards you just need to bring all the numbers across. So minus 5, minus 1 quarter, and this one will be 2.245 per y over 4. You multiply this by 4, you'll see that y is 9. Okay, so because of these two, then you can conclude the molecular formula is C5H9OH. Okay, one more thing to take note of this question is that when you want to divide by the molar volume, okay, when you want to divide by the molar volume, because it's in cm cube, so notice 1 dm cube equals to 1000 cm cube, so therefore if the molar volume is 24 dm cube, it should be 24,000 cm cube. Alright,